Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics.
Welcome to Speaking of Reliability. This is Chris Jackson.
And this is Fred Shankleberg. You know, I just saw a sports news thing the other day, and it's from your home country, tennis, Australian Open, I think it was called. It is called, and by the time this comes out, it'll be resolved, and whoever's winning is winning. But what's his name? The world reigning men's champion,
Novak Djokovic.
Yeah.
Yep.
So did Australia win on this immigration thing, or did World Tennis win on this? Or, I mean, what was the objective here?
On that one, that's look. There's a lot of feet in different camps. I don't think anyone came out looking very good. But the reality is, if you go to another country and you lie about whether you satisfy the criteria or not, then you run the risk of them saying no. And yes, to be clear, Novak was looking for an exemption that applied to people who are looking to get vaccinated to enter the country, because you have to be vaccinated. But people who have had COVID, which means it delays their vaccination, are allowed into the country. But you can't use that rationale to not get vaccinated at all. And it turns out he never had COVID until after he launched the visa application. So it was just, and during that time he said, yeah, I had COVID at this point in time. Well, obviously he turned up to a couple of events in France and so on and so forth without anyone knowing he had COVID. But he was issued a visa initially. And of course you're not supposed to issue visas and then take them back.
Well, so you can. You can.
Well, you can. You're not supposed to.
Not supposed to. No, that's true.
It's not a good look. I mean, but at the end of the day, this is. Most Australians believe he shouldn't have been allowed to enter because everybody else is being held to a certain set of rules. And yes, they were applied to him. He never intended to get vaccinated. And the only people who are vaccinated or couldn't get vaccinated but intending to get vaccinated are allowed to enter Australia. So that's what it is. What it is.
Yeah. But it's, I'm thinking of, we've got different mandates and different objectives and all these other things. And for a while here, at least in the U.S., it's get a vaccine, right? And get vaccinated. It keeps you out of the hospital, if nothing else. It doesn't guarantee you won't get COVID, but the objective was very clear. We need to get 80-90% of people vaccinated and we'll be okay. Right. Yeah, it's still not good, but it will be in way better shape than if we don't. And it's just been dragging on. And I've run into this in companies where, we'd like to be at 90%, everything works and we have this certain reliability, but then we find out in their testing that, well, it's only really going to last 85% of the time for 1 year instead of 90. And then somebody goes, well, that's okay. That's a corner case. We'll just move the goalposts. And, we keep re-rationalizing what we think we want to do and how we're going to achieve it. And then declare victory at some ambiguous, swampy marker that just finds what's good and not good. And I thinking of the Australian Open is that, they had a set of rules. Here's somebody that thought, well, I'm important enough and whatever, they can't afford not to have me in this event and vice versa or whatever. It'd be bad PR for him to kick me out. I'm like, well, he gambled and he was wrong on that one. Yeah. But like you said, Australia didn't look great either in the way they handled it. But they did. And I kind of like the idea that the guy got sent packing, but that's just me.
Yeah. I mean, but if you lie on any, if I travel to any country and I lie on any form of declaration I make, be it arbitrary or insignificant, they reserve the right to kick you out.
Yeah.
So
and that's not unknown. That's common practice. Yeah. And it's, I agree with that. Now, here's the thing though, when you put it into a product point of view and you say, yeah, my product will last 5 years and you shouldn't have any problems and blah, blah, blah. when I'm working with folks and I'm working with vendors, especially, it's like, well, how do you know that? What's your evidence? What's your support for this? What's the rationale why that will work in our environment? How do you justify your statement? Oh, it's just reliability. I'm like, okay, I'm going to move on to the next vendor because I have very low confidence that I'm actually being told the truth, or it's kind of squishy. And I've mentioned before, as Dick Moss told me that I was going to ask him about a problem. A vendor, we sent a part to a vendor, which is kind of the hard lesson I learned. Don't do that. And they called me back and said, "Oh, it's ESD." And I says, "Well, have you received the product? How do you know it's ESD?" "Oh, it's always ESD." And so Dick said, "Well, that's just number 3 on the 5 standard answers that vendors give you so that you go away. Don't bother them anyway." But it goes to that point of, well, what is good enough? And you've been in product design teams and reviews and stuff like that. And they says, well, if the color's not exactly the right blue, that's okay. We don't really care. That's fine. And then they say, well, if it weighs 3 ounces too much or too little, well, that's okay. That's within margin of error. And it gets fuzzier and fuzzier as to what's a failure and what's not a failure.
And it comes back to organizations that do this well have a very simple raison d'etre as a rule.
I did mention French, but you didn't have to throw out a bunch. Or is that Latin? I don't know what reason.
Raison d'etre is French.
Okay.
Reason for being.
Oh, okay. I didn't have any idea what it meant. I thought it was something to do with Rice Krispies or something.
No, but it shocks many of our clients, I would argue, or at least mine, when I say, look, some organisations who do this better than you, they don't test exhaustively the way you think you need to in order to have that level of confidence that your thing is going to be reliable or not. And they go, how do they know? How can you walk up to them and be confident that their product's going to last longer if they don't do testing? You go, well, ever heard of Apple? They test. Don't get me wrong. I'm not trying to sell them short, but they don't do this mindless, let's put 65 million iPhones on a test bed and see which one fails first. They really focus on understanding the weak points of each design. And yes, every design by definition has weak points.
And it gets characterized. They characterize those failure mechanisms. Yeah.
Right. So they're not going to give you reams of test data to demonstrate their iPhones last a long time. They just do. And everyone knows that. Yeah. And they are supremely confident because they know, with a simple philosophy on always finding the weak points and focusing your reliability efforts on those weak points, if you do that, if you genuinely do that, your thing is just reliable. But those organisations who don't have that really simple ethos, reliability becomes a metric you sort of need to satisfy en route to achieving something else. And to an extent.
Yeah, and unfortunately, some organizations define reliability as, well, I met all the standards. So I met XYZ standard tests, and therefore I'm reliable, which by and large has no correlation whatsoever.
Well, the blowout preventer on the Deepwater Horizon, that was built in accordance with standards. Mm-hmm. The standard didn't take into consideration the well-known failure mechanism that's led to, the blowout preventer wasn't constructed well either, but one part of it, the blind shear ram, was supposed to be the, fail-safe that ends all fail-safes. Mm-hmm. And then what happened was the drill string, which holds metal tube, which holds all the oil, was under such high pressure that it buckles. And when the pressure is so high, even when it's when it's a fluid, pressure is being exerted uniformly within the tube. But when the differential is so high, it creates this phenomenon, the name of which escapes me right now, but I think it's called local compression or something like that. Essentially, it makes the drill string buckle, and essentially the drill string was buckling and pushed to one side, and the rams, which are supposed to clamp shut and save the day, the drill string didn't stay in the teeth of the rams, and so it just went to the side and was compressed as opposed to sheared and closed. Mm-hmm. But that was built to a standard. Doesn't mean it's going to work.
No, and that's an extreme example too. I have seen some of this equipment. It's amazing equipment, and the folks I've worked with at the various oil exploration type stuff, really understand they don't want to do what Deep Horizon did. They don't want to have problems.
Correct. Yeah.
And it's not just leaking oil, it's killing people. Their equipment is amazingly dangerous.
Yeah.
And so but what I have a problem with is when you get to a group and they're like, one of my very first projects was with a hot tub. The other extreme from the high pressure oil buckling a drill string, it was a hot tub manufacturer. It was the above ground, you buy it at a hardware store or a spa and fireplace store, and you roll it into your backyard, fill it up with water, and get hot water, bubbly hot water to sit in there and relax. Yeah. Talk about low pressure, right? But the siding on this stuff was extruded and kind of made to look like fake wood. It was kind of cheesy looking, but it's cheap, and they could make a gazillion of these things and they'd stick them on there. They had no problem heating the water up and putting bubbles in it and all the other stuff. Everything else worked just fine, except the siding would fall off because of just the coefficient of thermal expansion. These things were extruded polymer, and in the long direction of that extrusion, it would expand and contract like an inch over the 2 feet or 2.5 feet that it was a plank. And it would move like an inch and a half. It would move a lot. And a piece of wood would move like a 1/4 inch over that distance. But the way they were attaching it, this thing would fall apart.
Right.
And so the first question to them is, when they explained this problem, is, well, how long is it supposed to stay there? And they had no answer for that. They had no idea. He says, well, it's falling off now, so that's not good. Well, if we make it last another 2 days, is that better? No, that's better. But it's like, well, how long is it supposed to last? And then they said, well, it's got a 6-month warranty, so it's got to last at least 6 months. Okay. Is that good for your business? Yeah. No. Because we'll get complaints and everything else. Yeah. Well, how long should it last? Forever. Oh, okay. Well, that's not possible. Let's redefine this. How long should your hot tub function and work? How long does the motor work? They had no clue. They built these things and shipped them out and fixed problems as customers complained about it. And that was their philosophy. And I'm like, well, what are you trying to achieve here?
It's, yeah, and then we get caught, I suppose. I mean, I understand where you're going with the whole, what's our reliability supposed to be? How long characterize the use case? And that's also always very important. But it does sometimes create this scenario that we keep working on it until we're there. We keep working on it until we're there, until we're there. Once we're there, we stop and have gin and tonics and relax.
Oh, get in the hot tub.
Focus on all the fun stuff. Get in the hot tub. But again, those organisations that do this better, they have requirements, but they're almost sometimes inconsequential because they just know that they do what they do, and those requirements will be easily met.
Well, you've talked about, is it Netflix that does the I'm trying to think of the name of it. It was like chaos testing?
Simian Army, yeah, which is Chaos Monkey, and
yeah. But it was just and so they're not saying, and I get your point. I hadn't thought of it that way. It's not setting a clean, crisp goal. This is what's a failure. This is not a failure. This is, performance we're trying to achieve. This is not performance we're trying to achieve. But if you flip that on its head and say, we just want to be better and we want to make it work and keep making it better and keep making it work, then you create a Simian Army kind of approach. Yep. It's not like they get 98% reliable over 10 years. No, that metric is meaningless to them. It just needs to work. Right.
And their system is constantly changing. New technologies, new server technologies, new customer demands. Netflix started from just sharing existing videos, then moved to, we're actually going to create our own. So that introduces a whole new level of data upload and download requirements and all sorts of things that the original business plan didn't really, I suppose, couldn't have possibly characterized perfectly. But at the end of the day, they don't measure reliability. They spend every reliability-related resource on improving reliability, and so they are reliable.
Well, this is what Kirk and Greg Hobbs had been with Halt approach to product development is, and it goes back to Bill and Dave, Hewlett Packard team, is build, test, fix. Find the weakness, make it better. Find the weakness, make it better. And when do you stop that process? Well, when the customer is willing to give you money for it. It was kind of what the Hewlett Packard one was. And for Hobbs, it was, what's your shipping date? Well, that's how long we got to go. You can't do better than that. It was kind of the approach. But I don't know. I have long been of the mind that, well, no, I take that back. I'm thinking of an example where I was working on a medical device and they had a bunch of field failures and they had it defined to these different, I think 5 different subgroups within their product. And they had pretty decent data for these 5 subsystems and how many failures and all this stuff. And so we put it on a plot and did a Weibull curve basically for each of the subsystems. And, early on they needed to fix these 3 issues. And later on, it was this wear out mechanism that was cropping up and you needed to fix that. But it was that approach. Where are the weaknesses? Let's go fix those. And that'll overall improve our reliability. And the question came up was, well, how reliable do you need it to be? And the conversation quickly went into, well, you only have 3 competitors. How reliable are they? Mm-hmm. Well, let's go figure that out. And so we got we did 2 things. We tore down the competitors' products, and it was really interesting things they figured out from that. And then they put a handful of them on just a competitive test, which ones will, and these weren't, they're super long lasting products in and of themselves. This is the way the technology was. So it didn't take long to show clear differences, not of how long they lasted, but how different parts of the systems would perform better than others. And so they kind of said, well, let's take the best of these different solutions and incorporate it in our product. And we just have to be better than the competition. We don't have to be X number to something else, which the quality folks really hated because they didn't have a number to measure to compare. Say, are you there yet? Yeah.
It's
I got to rethink how I talk about reliability, I guess.
I mean, it's useful. I mean, and I'm cautious of using the phrase build, test, fix because I don't advocate build, test, fix, but by the same token, there's different interpretations of build, test, fix. So you can look at military reliability growth where you build it, you test it in at-use conditions, and you fix problems as and when they come up. But that takes a long time because you're just waiting for what should be a reliable product to fail when it's being used in at-use conditions. And the reason why military people love that approach is because it quantifies reliability as you go along. Mm-hmm. But I've seen reliability growth trials last for years. It's just, in my opinion, an insane...
Well, it works great on tanks and helicopters because they fail every 3 minutes. Or something on the system fails pretty quickly.
Right. It's and so that's one approach to build, test, fix. Then you could say Halt's a completely different flavor of build, test, fix. And I'd agree with that, where you try and get a prototype as early as possible and you test it until failure, and then you keep testing until it fails even harder and even more violently. So you really, really understand how those weak points are going to manifest themselves during at-use conditions. Yep. Both build, test, fix, but very fundamentally different in your approach. And I'd also argue that things like familiars and fault tree analyses, which you do before you start building prototypes, in a way is build, test, fix, in that you're sitting down and you're building it in your mind and saying, well, how can it fail? And you write it down using corporate knowledge.
Yeah, and then you go do the investigations or experiments or engineering work or simulation work to say, all right, well, if we know that this wears, then let's change the material or let's change the approach or the angle or the pressure or something. But they're already solving a problem before it even had a chance to show up, which is it's perfectly fine. And none of those lend themselves to that you want to be at 98% reliable over 2 years.
Well, the only approach that lends itself to are we there yet questions is the third one. Well, the first one I'll mention, I should say, where you have that build, test, fix in at-use conditions, traditional reliability growth trials, which take years in some cases. But you can work out when you're there. But if you had used the other two approaches as your dominant approach to designing reliable stuff, you would have a much more reliable thing a lot earlier. Just probably wouldn't be able to characterize the reliability as much, and that's where people will start getting itchy.
Yeah, no, I'm thinking of, you set a system goal and it's based on customer requirements or warranty, accrual targets or profitability, all these other things. It's a measure of the probability of failure over time, environment, functions, and so on. And then you allocate it out. I think I'm just trying to say, well, because it very quickly then crosses over into where's the weakest point. So if I do an allocation and I go out this thing and I often use the story of a computer where the keyboard guy is like, oh, this is great. We have no evidence whatsoever. Our products, fail except once in a million times. And we're using the exact same one we've been using for 5 years and blah, blah, blah. We got this. We can meet these numbers. And so I'm not going to improve it, which I think is a good thing. Let's not put resources in improving a subsystem that doesn't need improving. And it goes back to your point. Well, what about this new nanotechnology you're doing in your CPUs? Is that the weakest point now, or is it something else? Where is the weakest point? And so I'm thinking setting the objectives for business and customer expectations, but avoiding are we there yet? But using that knowledge and modeling and allocations and system modeling and everything else to identify the weakest links, to identify where we need to focus on. And FMEAs and others, our tools are an additional way to go about doing that.
Right, but those requirements are still brutally useful, especially during FMEAs and even halt testing, because they will identify those failure mechanisms which are going to ruin your day. But you don't have to test till failure in at-use conditions to understand how long it's going to take for that failure mechanism to cause your thing to fail. So the requirements are still completely useful. It's just that a lot of people, it seems hardwired into their psyche that if you have a requirement, it has to be tested in exactly the same way the customer's going to use it or the user's going to use it for you to be able to say that it will be in spec or not.
Yeah, and you get some of them to bend a little bit and do accelerated testing, which is fun.
Yep.
But you can also, and I think the most successful accelerated tests that I've worked with and worked with teams to do were to understand, the pattern towards failure, or how, we really have a design intent. This product should last for 10 years. And use conditions, it would take us 10 years to know if we made it or not. So accelerated testing is useful to know, what's the probability of us getting this failure mechanism before 10 years? And that's a useful traditional reliability thing. But I need the number. Well, how many need to survive to 10 years as a comparison to the test results? How do we answer that question? Because if I run a accelerated life test and I show them a Weibull plot, there's a finite chance something's going to fail in the first hour.
Yep. Is
that acceptable? And that's where setting formal 4-part reliability objectives, it gives you a point of comparison saying, well, if 99 of them survive 10 years, then we're good. Okay. There's a hard marker for you. Now I can judge that experiment. I'm trying to rationalize the stuff I've been teaching for 10 years here. Give me a break.
I think it comes down to it's requirements. You need to have requirements. You need to have goals and specifications and things like that. And they need to be relevant. They need to be well defined. All the stuff we've talked about in the past. But if you walk up to two organisations and you say, well, how do you do reliability? Well, we do best in class activities. We have training this, we do that, we test this, that, and the other. You start all those sort of answers which explain where essentially they're explaining or characterising their efforts.
Yeah, their activities, yeah.
Whereas another organisation might say, well, we are all about the FMEA. We do a FMEA. We train people on FMEAs. The FMEAs are going to be this way, the other, or that another organisation might say we are all about halt. We do this.
Mm-hmm.
We try and we have a philosophy where we teach people about halt. We have our own halt facility, so on and so forth. It's those organisations that answer with a philosophy versus a description of their efforts that you really need to start buying components from, because they're the ones who tend to take reliability seriously. They have a very simple approach. Netflix would say, well, we don't do Vermeers, we don't do halt, but we have this thing called the Simian Army, and every hour we try and essentially break our system in a controlled way to work out its weak points, and we design that weak point out of the system and move on. And they explain their philosophy. Mm-hmm. Whereas those organisations say, well, we're ISO this qualified.
We meet all the standards that our customers expect us to meet, and we put it on our data sheet. So therefore, it's reliable. Yeah. No.
Yep. they're the ones that or reasonably suspect won't make reliable stuff that won't even try to attempt to meet their specifications they advertise.
Yeah, no, there's all kinds but for every one of those, though, you can get a slick story, but the proof's in the product. I've seen some that are just brilliant at telling you what they think you want to hear.
Yeah,
and it usually doesn't last very long when you go walk the line and go, that doesn't seem to be consistent with your approach that you've just spent 2 hours trying to bore me into believing. So anyway, I'm glad. I think the main point, and I need to figure out a better way of articulating it. Setting an objective or a goal or reliability requirements is good. I don't think that's wrong, but I take your point. It's how you approach it. It's how you go about doing it. Are we there yet? I'm thinking of, 3-year-old in the back seat. Are we there yet? Are we there yet? That's not the point. The setting the goals and the things gives us a marker in the ground, but it's the approach or culture or philosophy of how do we achieve reliability for our products or systems is more important. The culture is more important.
And the reality is you can only sometimes find out about reliability or measure reliability performance years after you make the decision on how to make that thing reliable. So you won't get immediate feedback. You won't have this you won't have this visible LED screen on the corner of the design room. Where
today you're at 92.3%, and it's going up over the trend of last week.
Doesn't quite work like that. So you have to focus on your philosophy, and those organisations who focus on their philosophies, you can say, hey, we're all about Vermeers, or all about halt, or all about Simian armies, or all about this. They're the ones that you should give a second look to, because they're the ones who are able to explain a philosophy as opposed to trying to wow you with expansive descriptions of the effort they put into making state-of-the-art this, that, and the other.
Mm-hmm. Yeah, no, good point. So if you're listening to this, and now I'm curious of how do you specify reliability? But more importantly, how do you approach achieving, creating a reliable product? And what's your take on this? How do you view this thing? And I know I'm just on the tip of my tongue. There's a bunch of stuff, but I'll make some notes later for another episode. But I'm curious, if you're listening to this, what's your thoughts or reactions? What would work or not work within your organization or with your industry of how things are done or not done? What would make a difference such that you would stand out and create reliable products, that kind of thing? You can do that over at accendoreliability.com/go/SOR. There's a SpeakPipe widget. You can leave us a message, or you can write one. There's a comment form there. You can find Chris or I or the other hosts of the show on LinkedIn or on our About pages. There's plenty of ways for you to join the conversation. All right, Chris, we'll talk to you soon.
Have a good one, Fred.
Cheers. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.